Hi everyone. The next topic is linear grammar. So a linear grammar is a context-free grammar that has at most one non-terminal symbol on the right hand side of each grammar rule. In general, we have a grammar consisting production rules consisting of two parts, LHS and RHS. If you have a uh, at most one non-terminal, remember this, at most one non-terminal symbol on the RHS, that context free grammar is said to be linear grammar. These are the examples: S to A, S, B, one at most one non-terminal, here at most one non-terminal, okay, here also at most one non-terminal. Okay, context free grammar means left hand side consisting only one non-terminal, but in that linear grammar means right hand side at most one non-terminal. Okay. The linear grammar is actually classified into two types. One is a right linear grammar, the second one is the left linear grammar. So when comes to the right linear grammar, the production rules are having the form A to XB. XB, if you observe this, A is a non-terminal on the LH side and X is a terminal on the RHS, and B is a non-terminal on the RHS. Okay, so in the RHS part, the non-terminal present at right side, then that is said to be right linear grammar. Only one non-terminal in RHS side, and that should be also in the RHS side. Okay, so or else A to X, so no non-terminal. So this is an example. S to AB. S is a non-terminal on RHS, only one non-terminal, at most one non-terminal, and it is present in the RHS side. Okay, and next one, left linear grammar. So left linear grammar consisting of production rules of the form A to BX. So from the previous one you can easily understand this. What it mean? So we have a non-terminal on the RHS. Okay, only at most one non-terminal, and it is actually a leftmost one. Okay, so rightmost one means right linear grammar, leftmost means left linear grammar. Okay, so context free grammar consisting only one non-terminal at LHS in the production rule. So I am repeating what is actually context free and linear, and what is right and left linear grammars. So generally grammar can be represented with the production rules. Production rule consisting two parts. One is LHS, the second one is the RHS. Okay, so context free grammar means in the production rules only one non-terminal exists at LHS side. That is context free. In that context free, linear grammar exists only, at most one non-terminal present at RHS, that is linear grammar. In that linear grammar, left linear grammar is there, right linear grammar is there. Left linear grammar means, so the non-terminal exists on RHS, but it is actually leftmost one. In the same way, in the right linear grammar, the non-terminal exists at RHS, at most one non-terminal RHS, but it is a rightmost one. Okay, so that is the thing. Context free linear grammar, right and left linear grammars. Okay, these are the examples. So there is a possibility of conversion right linear grammar to left linear grammar. So first go with the conversion of right linear grammar to left linear grammar, LLG. So the steps involved: first convert the given right linear grammar to FA, finite automata. In the first unit we see the finite automata construction. Set of states exist, and set of transitions exist. Okay, transition consisting some labels, those are nothing but terminals and all. We discussed many things in the first unit. So we have to construct a FA. Okay, so interchange the initial and final states of FA. So initial state represented with a circle with an arrow, and the final state is represented with two circles, right? So in that circle we define a name of the state and reverse the directions of all transactions. In the FA we have a set of transactions, so we reverse them, and finally construct the regular grammar for this FA. Okay, now so let's go with an example. So here convert the following grammar. We have RLG. Why? Because only one non-terminal at LHS, context free, and at most one non-terminal exists RHS, that is linear, and the non-terminal is rightmost one. Okay, then this is called as a right linear grammar. Okay, now we have to convert this into the LLG, left linear grammar. So first convert this into the FA. We already know how to convert a grammar into the FA. You have to remember. I don't know whether you are remembering it or not. So let's see. So first production rule in the grammar, S to A terminal to capital A non-terminal. So how we can define this? So S is a start symbol, circle with the arrow. In that we specify S, name of the state, and to another state capital A, the transition, the input from the input to the A is nothing but A. Okay, the transition label is nothing but A. So first production rule can be defined like this. Okay, so next for the next production rule, what is the next production rule? A to BA, BS A. Okay, A to A we have a transition, the label is B, the input is B. A to S we have a transition, the input is B, and A to A we don't have any non-terminal symbol here. That means this is a transition to the final state. Okay, we don't have any non-terminal, means this is a transition to the final state. So A to A we have a self B, A to S we have a transition B, A to final state we have a transition A. Okay, so this is the total FA for the given right linear grammar. Okay, this is the final FA for the given grammar. Okay, so what is the second step? Second step is nothing but interchange the initial and final states. Okay, here the initial state is S, the final state is C. Okay, now we have to interchange. So then in this second step, the initial state S become final state, the final state C become initial state. The third step is reverse the directions. In the previous diagram we have a transition from S to A, that is A input. Okay, the same can be interchanged here. From A to S we define a input A. Okay, like this, A to S B, here S to A B. Okay, like this we can reverse every direction of the FA. Okay, now by using this FA we construct the grammar. Okay, so from start symbol C to A we have a input symbol A. Okay, from A to A we have, from A to S we have A. Okay, and S to A we have a B. Okay, so here A to S means S is a final state, no need to specify any state, so that simply we can define A here. Okay, so we convert this FA into the given grammar, and into the grammar. The final grammar is nothing but LLG, left linear grammar. Okay, hope you understand. So simply 4 steps to convert right linear grammar into the left linear grammar. So first one, you have to construct a FA based on the grammar. Next one, you should reverse the initial and final states and interchange the, and the next one you should reverse the every direction of the transition lines. So finally you construct the grammar. Okay, grammar to FA, FA to grammar, we did it here. And the same way also we can perform the conversion of LLG to RLG. First we have to construct the FA for the given LLG, and the next one we have to interchange the initial and final state, and we have to reverse the all directions, and finally we can get the grammar for the FA RLG, right linear grammar. So this is the grammar. S to AA, S to AA, S to B we have a B input, and A to BB, A to B we have a B input. If you observe the grammar, we have a at most one non-terminal on the RHS, and it is actually at a right, rightmost one. So that's why it is called as a sorry, actually it is the leftmost, right? So somewhat myself also confusing, so you don't get confused. So here we have a LLG, right? So LLG means at most one non-terminal in the RHS, and it should be leftmost one. Okay. Convert the given left linear grammar. If you have any doubts, you can ask me, don't mind. Okay, don't hesitate. Somewhere I am confusing about a terminal, non-terminal, and the same way right and left. Okay, you don't get confused. If you have any doubt, you can again ask me. Okay, so this is LLG. Okay, we have a non-terminal at a leftmost in the RHS. So first you did construction of FA, and after that you can interchange the initial and final states, and after that you can reverse all directions of the transitions, and finally from the FA you can get the grammar. Okay, so that is about conversion process. So context free linear grammar, in that right linear, left linear, and conversion of left linear to right linear to left linear. Okay.